Alrighty, let's continue with the Unit 1 review. Number 16 wants us to find the distance from point A to point B. The distance formula is the square root of x minus x squared plus y minus y squared, essentially. I'm going to use the Pythagorean theorem model for this one. First thing, let's build our right triangle. Connect A to B. Alright, so count the sides of our triangle. 1, 2, 3 over here. 1, 2, 3, 4, 5, 6, 7 over there. Using the Pythagorean theorem model, what I have told my students is that you can take C is equal to the square root of A squared plus B squared. Knowing that as a fact, we have A already, we have B, we're looking for C, which is the distance from A to B. So A to B is going to equal the square root of 3 squared plus 5 squared. 3 squared is 9. 5 squared is 25. 9 plus 25 is going to give me 36. And then the square root of 36 is 6. So the distance from A to B is 6. So again, you can choose whichever formula to use for this situation. If you have a grid, using the grid to draw a right triangle might be the easiest method. All right, next one is number 17. And number 17 wants us to find the distance between x and y, and they don't provide us a grid. So this one might be, in this situation, it might be best to use the distance formula. Again, we have our distance skeleton, is what I like to call it. Have that square root, have your parentheses with your minus and squares in place. And then insert the appropriate values in the appropriate spots. So it's x minus x, x minus x, so that's negative 4 plus 3, or 5, sorry, because of the double negatives. And then it's y plus y. One y is 9, the other one is 3, so 9 minus 3. Bring down your skeleton and take care of everything inside the parentheses. So inside the first set of parentheses, it's negative 4 plus 5, so that's a positive 1. Inside the second parentheses, it's 9 minus 3, which is 6. All right, and now we're going to square everything. One squared is simply 1. 6 squared is 36. One plus 36 is going to give us 37. So our answer is the square root of 37, which is a great answer. But if you want to see what that would compute to become, grab our calculator. To do the square root, you do second x squared. And now type 37 and hit enter. You would get approximately 6.08. So approximately 6.08. Both are great answers. Either leave it as a square root of 37 or approximate it to 6.08. Number 18 would like for us to find the coordinates of the midpoint of JK. Again, it's on a coordinate grid. The formula for midpoint on the coordinate grid looks as follows. What I put in red will be the formula skeleton. And then it's x plus x, y plus y. So for JK, again, draw my formula skeleton. And insert the correct values in the correct location. So my x's are 5 and -4. And my y's are 12 and 8. And then we're going to do this one without a calculator, but in order to do it in the calculator, you would have to do each fraction and hit enter individually, not all at once. So so 5 plus -4 is a +1. So you have 1 over 2. And then 12 plus 5. I believe that's a 5. Let me double check. My pen got in the way of my right of the actual problem. I'm sorry, it's 12 plus 8. Good thing I checked. It's 20 over 2. So you could leave it as 1/2, and then 20 divided by 2 is 10. So the midpoint is 1/2, 10. Number 19 would like for us to name an angle that is not adjacent and not vertical to angle STP. Ooh, that's a doozy. So let's highlight angle STP. STP. P is that one right there. All right. In order to, let's talk about what this means. Adjacent, next to. So they share an entire side. Vertical is bow tie. So the bow tie angle would be QTR right here. So we don't want that one. Adjacent angles would be angle PTQ and angle STW. They're adjacent. So we don't want adjacent and we don't want vertical. So the only angle that remains in the picture could be angle WTR, or backwards would be angle RTW, because it's not one of the ones that I've identified in the picture. That was a good question. It required a lot of thinking. You need to know what adjacent meant, and you needed to know what vertical meant. All right. They want us to now find the value of x. X is found in angle ST. Oops. Let me use the highlighter. X is found in STW and WTR. So what you should realize about these two angles is that they are a complementary pair. Since they are a complementary pair, together they add up to 90. Good. So we're gonna set up the format where it's angle plus angle equals 90. So that means that 2x plus 5x plus 6 should equal 90 degrees. All right, so combine our like terms, 2x and 5x, you get 7x plus 6 equals 90. Subtract both sides by 6. And you would get 7x is equal to 96. Then divide both sides by 7. And I probably need my handy dandy calculator for this one. 96 divided by 7. It's about 13.71. So x is equal to roughly 13.71. Oh my goodness. I just realized I made a mistake. I was subtracting 6, and in all actuality, I added 6. So let's fix that right now. I showed subtraction, but I still added. Alright, so it's supposed to be 84 divided by 7, which would probably be a better answer. 12, yes, definitely a much better answer. So x equals 12. Final answer. All right, we're going to use this figure for the next few problems. 21 says, does angle XVY appear to be acute or obtuse? So let's highlight the angle that we were referring to. XVY is this angle here. And I would have to say that angle XVY appears to be acute. Because if you were to take a sheet of paper and line it up with the corner, which is exactly 90 degrees, then you would see that angle XVY is a little less than 90 degrees. Number 22 would like for us to name an angle that is vertical to angle YVZ. So let's highlight that angle. YVZ is this angle here. To be vertical, you have to form a complete X together with another angle. And that angle would be WVU. Those two form a complete X when they're put together. So again, it's angle WVU, or you could say angle UVW. Hold on, let me change my view. I gotta be able to see the picture for all of these questions. Okay. For number 23, it says name an angle that is supplementary to WVX. So let's highlight WVX. All right. In order to be supplementary, together the two angles have to form a line. So I would have to say that it would be angle XVZ. Or angle ZVX. 24 wants to know an angle that would form a linear pair with angle WVU. So let's highlight angle WVU. To form a linear pair, you have to be adjacent and form a straight line together. So to be adjacent, you have to share that side. So there's a couple of options. One option is angle UVZ. So let's write that one down. But that's not the only one. You could also say angle WVY. Again, they have to be adjacent and form that line together. Number 26 says the measure of WVY, let's highlight that real quickly. WVY is 130. Then what is the measure of angle WVU? WVU. Well, since together they are supplementary because they're a linear pair forming that straight line, and supplementary means they add up to 180, then the measure of angle WVU would have to equal 50 degrees. Because again, it's supplementary with the 130-degree angle. On number 26, it says that angle WVU, let's highlight it. Now, if you're doing this at home, all this highlighting will become overwhelming. Trust me and believe me. So it's best to trace each situation for each question. You might want to do it on separate paper because, again, it's going to get to be too many distractions on one picture. So again, you probably want to trace it. Angle WVU. It's this angle here. And we need to highlight YVZ. YVZ. So together, what you should notice with my highlights is that both of those form a complete X, sharing only the vertex, which means that they are a vertical pair. And since they're a vertical pair, their angle measures are congruent. So for number 26, we're going to use the format of angle equals angle. And with that being said, we can now say that 35 is equal to 5x plus 10. And now we can solve for x. First things I would do is subtract 10 from both sides. Which would leave me with 25 is equal to 5x. Then divide both sides by 5, and you would have 5 is equal to x. Boom. Let's take another break at this point and resume in just one moment.